guy to Let me see the production. No, we can't see it. We can't see it yet. Okay. Because it never connects.
Good afternoon, ladies and gentlemen. Please want to ask our students sitting over there, please come to the middle. Please come to the middle row. Thank you. Let's sit together. Please come to the middle row. And also for persons sitting at the extreme, please come to the middle as well. Thank you. Let's sit together. Nice to meet you. Please, you can sit on either tutorial, this way or this way. Please begin from the middle. Those are the left and the extreme. Please come towards the middle. Please, let's come together. Some students are not this way.
Oh my God. Okay, you did that. I don't understand though. CBS said we now know till June 1st. So really true.
Which company carried the news? Company news with that. Click the link and check the company that has the news.
Really June 1st. What are the punishments now? I don't know which one is news direct.
What's the date on the news? Today.
Today. Anyway, they're very small and they're very good. Yes. This is title. My first one. Is it very special?
What have happened to those power cables now?
What do you want to find?
Even if we carried it, we didn't bring out this stuff. We already knew that we're not going to.
I know people brought it out when people were bringing out your tools.
We
forgot to
knew we're not
put it
going to record. We knew we're not going to stream, so we didn't need to set this one up.
At first, we did not bring this laptop.
We don't even carry laptop.
No, even if it's not laptops, all I'm talking about. Since people carry the bag, when that people were bringing out extension, people don't use the extension.
Extension camera.
Yeah, as people were moving it, you know, say first, you first remove the cord first, before you move the extension. Maybe now not put the extension back.
No, we take
They not put the cord.
We look proud. If you take our Bushal,
What's the name of the phone?
It's very small and it's very large.
That's what they told you.
it's very smart, that's the topic.
Whether they named the file like that. Look at it.
Time is streaming tools.
Yes, let everything be in one place.
Careful.
Yeah, so.
It's not you to research.
Yes, we are two and one.
Hey, remind him about this cable for this.
Cable for so we can go live.
This I call this thing again, sir.
USB cable.
No, this device.
Capture card.
Capture card. Yeah.
Stand look at the crowd. You know just stop students.
My brother, how are you? Very fine. Now the family is very fine, and you too. I'm good. What of your sister? She's very nice. Listen.
I have 10 minutes to keep this shit up.
I know some of these things just take it on.
Solo no put game today.
When they don't see any game where
We're sure.
but later now you now check that you just see it don't run so.
You know when Leeds was 2-0 up, did you check the odds for Man United to get it wrong? Yours
It
eight.
was a lie. It was all
3 after
I carried it to our draw. It was 3 odds. It was not about to think, it was 280 something when they were 2-0.
2-0.
For Man U to win, 2-0 was 3 odds.
It can be.
I think when I carried the live betting now, I said I will find them again here. Draw and when it was 2-0 was 2.8 something odd. Then to win was 3
Maybe that
something
is
odd.
to win 3 points something. No,
I'm
that's
telling
not right. That's not right. That's
So,
not right.
I told you, I played
now.
it
Winner
now.
is man.
Told you I played
Another
the
game
game
cut.
now.
Another game cut.
You cut her now. I'll go my history now, bring it out.
And let me show you one game that came
I'll
to
go
my
my
mind.
history
That
and
game I
bring
wanted
it
to
out.
play only it. The game was a 3-ordered game. 3-ordered. You know that game before?
I come. So this man no just gets,
Just.
you know, get pictures from the beginning to the end, not today. No need for the slide there now.
Good afternoon, ladies and gentlemen. Please stay right to receive the Vice Chancellor's speech. The Vice Chancellor's session is led this afternoon by the Deputy Registrar, Senate Matters, Mr. Emmanuel.
Last continue. Let's make sure you get captured.
So,
The session comprises of Provost, College of Medical Sciences, Deans of Faculties, Directors of Academic Programs and Institutes, the lecturer, principal officers of the university, and the vice chancellor.
So now they wait for Mobu Bahan to
what
win.
you carry away? The way we win now.
Okay?
They don't start.
It's after. So the game all have big because the first one we play. The other take 3.1. This Kenya game I can't play. Morocco.
Mayu. Aka Mayu draw and leads to win. That was center. Now fair over 2.5. There is another team who got out.
Funny enough, the way this game plays, I see cash out of pressure.
United Anthem. The Vice Chancellor, the very distinguished Professor Lydia Salami, represented today by the Deputy Vice Chancellor, Academic Professor Ray Osoba, other principal officers of the university, provost, deans and directors, professors emeritus, other professors and scholars here present, government functionaries, your Royal Highness,
Running very well.
staff, students, invited guests, ladies and gentlemen,
Wow.
this afternoon it is my pleasure to welcome every one of you to today's inaugural lecture. This is the 271st inaugural lecture series of the university to be delivered by Professor Emmanuel Osayomwanbo Aiyohuyin, a distinguished professor of high energy, physics, and cosmology, on the topic the very small and the very large. May I now invite the registrar, Mr. Demola Bobola, CIPM, to introduce the Vice Chancellor and members of the Vice Chancellor's procession.
I think we should put our hands together to applaud Mr. Vice Chancellor, sir. It is my singular honor and privilege to present to us today the principal officers of this university, deans and directors who are in the Vice Chancellor's session today. First, the number one citizen of campus, the amazing who is very dynamic and bringing the University of Benin to the forefront in the entire university system. The chairman, Committee of Vice Chancellors of Nigerian Federal Universities, and of course the Vice President, Association of African Universities, Professor Lydia Salami, the Vice Chancellor. As you are aware, this is a very auspicious time in the life of our country. Vice Chancellor is very busy with so many official assignments here and there. But the Deputy Vice Chancellor academic who is standing in for me will do more of explanation about the Vice Chancellor's presence at this occasion. It is therefore my singular honor and privilege to present to us today Emmanuel is standing in for the Vice Chancellor today, a distinguished pharmacist and the Deputy Vice Chancellor Academic Professor Osayomwanbo. And our Vice Chancellor is assisted by the Deputy Vice Chancellor Association, a distinguished Professor of Medicine, Professor Mrs. Catherine Forward. And of course, we have the Deputy Vice Chancellor of our Inaugural campus, and Emmanuel is trying to take the battle today. The first we are likely to see on this podium next week, Professor B.A. and the Deputy Vice Chancellor. I'm sorry to have left the cat out on the back. I hope the chairman of the Inaugural Lecture Series will not penalize me for saying that. Today we have with us the representative of the author of this university, Dr. Dominic Aiyohuyin. Of course, we have with us the custodian of our books and publication, and of course, the distinguished Professor Luke of us, University Librarian. The provost of our very reputable College of Medical Sciences, Professor Wilson is here. Dr. S.A. Aiyohuyin is standing in for the Dean School of Postgraduate Studies. The Dean of our students, may I say that we have close to 60,000 students, both within and different parts of the world, as foreign students. The Dean of Struggle and Dean of Students, and Dean of Stress, but all of them, Dean of Solutions. Professor A.C. Inaugural is the Dean of Student Affairs. I'm sure with the students going home for some time, the Dean will have some time to rest. The post-Dean of today, of course, a very distinguished professor, and the Dean Faculty of Physical Sciences, if phone and still are not properly served, you can draw his attention to the Professor D.E. Seweka. The Dean of the Faculty of Arts is Professor S.C. Yuka. We have a brand new Dean in the School of Dentistry, who is being re-elected and is celebrating that today. You can also join the program lecturer to increase the rights of skill and everything. Professor F.O. Orange. The Dean of Faculty of Education, who a few moments ago I was asking where is our Vice Chancellor, because he's the Dean of the Vice
pick am when you dey add.
joined the services of the university in 1996 as lecturer 1 and rose to the rank of professor in 2012. His primary research focus is nuclear physics, high energy physics, and cosmology. He has held several administrative positions within and outside the University of Benin, such as the head of the Department of Physics in the University of Benin 2010.
The very large,
48,
these are the gargantuan structures that are to be found across the universe. These are the planets, the stars, galaxies, black holes, clusters of galaxies, and some other massive structures in our universe. Madam Vice Chancellor, during the course of this lecture, I'm going to attempt to explain to us how the material world came to be. I'm going to explain to us how space-time came about. I will in fact be explaining to us the origin of our universe. I will not stop there. I will go on further to posit how this universe will end, if it will end. These questions are some of the questions that have challenged humanity since the first man emerged on the surface of this world about 7 million years ago. That was when the ape-like man came down from the trees and walked on tools for the first time. The universe contains four fundamental forces. Gravitational force, electromagnetic force, the weak nuclear force, and the strong nuclear force. The gravitational force is the interaction between two matter particles, and the carrier of the gravitational force is the particle we call the graviton, which has a spin of 2. The electromagnetic interaction is the interaction between two charged particles. This interaction is facilitated by the particle we call the photon. The weak nuclear force is the force that is responsible for the process of radioactivity, or what we call nuclear material decay. This force is facilitated by two types of particles we call the W and the Z bosons. The electromagnetic force and the weak nuclear force at a very high energy become one force that we call electroweak force. This energy around the neighborhood of 100 giga-electron volts. That may not be too much to many of us here. However, that energy is high. At that energy, we say the symmetry between electromagnetic force and the weak nuclear force is broken. The strong nuclear force is the force responsible for holding the nucleons together in the nucleus of the atom. It is also responsible for holding the quarks together inside the nucleon. This strong nuclear force is mediated by another particle we call the gluon. At a very high energy, however, the weak nuclear force, the strong nuclear force, and electromagnetic force can become one if the energy is high enough to the neighborhood of 10 quadrillion giga-electron volts. I just want to mention quickly, at this junction, there is no nuclear accelerator where we perform experiments on subatomic particles to generate this kind of energy. However, early in the universe, this energy was attainable. We have a theory we call the grand unified theory. This theory is responsible for uniting these three forces: electromagnetic force, the weak nuclear force, and the strong nuclear force into one force at this energy. And at this energy, as I said, there are certain predictions that a proton, for instance, can spontaneously decay into an anti-electron. This was what happened in the early universe, when the universe was so hot. However, if this transformation were to be symmetrical, it means in the universe we should have equal number of anti-material and material. If that were the case, the nature of matter and antimatter is that when they come in contact, there is mutual elimination. Our universe would have been very, very dull, very, very uninteresting if all we had was just equal number of particle and antiparticle. However, this spontaneous decay of proton at that high energy into anti-electron is asymmetrical. There is an excess of matter over antimatter. Because of what we say in physics, the violation of the time symmetry. Why there is a violation of time symmetry is another story for another day. Due to the fact that some forces do not obey the symmetry time, it follows that the universe expands, more anti-electrons turn into quarks than electrons turn into quarks. In the long run, it's more excess of quarks remain. It is this excess of quarks that remain that now turn into the material world that we see around us today. However, gravity, the fourth force, is so weak and is not important, so much so in high energy physics. However, because of the massive material in the universe and the cumulative effects of gravity is important and it dominates the evolution of our universe. Einstein was the man that came forth with the hypothesis that we call the general theory of relativity. It's actually a classical theory of gravity. Based on this theory and its equations therein, we are able to trace the evolution of our universe from time zero to the present time. And that evolution is what we are about to embark upon. 14 billion years ago, our universe was born from what we call the Big Bang theory. All these are all embedded in the general theory of relativity. At that time, the universe must have been a very dense and high temperature quantum system. However, there is a problem in the Einstein general theory of relativity. It cannot go far below 1 second. So we do not really know what happened at time very close to 0 seconds. We can only apply this theory to the evolution from 1 second after the Big Bang to the present moment. We say that to do work at that time close to 0 seconds, we need another type of physics, which we call quantum gravity. A second after the Big Bang, the temperature of the universe would have fallen to 10 billion degrees Celsius. At this time, the universe would have contained mostly photons, electrons, neutrinos, neutrons, and protons, and their antiparticles. As the universe continued to expand, the rate of production of electron anti-electron pairs would have fallen below the rate of annihilation of the same pairs. A few seconds after the Big Bang, the neutrons and protons would have formed a heavier nuclei we call the deuterium nuclei. These have led to the formation of helium nuclei and also small amounts of heavier nuclei like lithium and beryllium. A few hours after the Big Bang, the production of helium and other elements would have stopped. The universe continued expanding in the next few million years. At this time, in the evolution of the universe, everywhere was still dark. There was no light. When the temperature was sufficiently low enough, the nuclei and electrons would have started combining to form what we call atoms today. Expansion of the universe would have slowed down in some regions because of the slightly dense areas. And this expansion would have stopped altogether in some regions. Those regions where expansion stopped altogether, the hydrogen and helium gases would have broken up into smaller clouds and collapsed under the force of gravity. Because if you take a system that is voluminous and you try to squeeze it into a smaller volume, what you get is higher temperature. As these clouds were collapsed under gravity, the temperature was increasing. A point would have been reached that the temperature would be high enough to cause nuclear fusion. And when that happens, the system will become stable. What I have just described is how stars are born in our universe. All the stars we see in the night sky were born like this. Our local sun is a star. That was how that sun was born about 5 billion years ago. Such a star system will continue burning so long there is hydrogen gas present in it. So it will remain stable. That stability will not remain forever. Our sun will not continue to shine forever. In fact, from all calculations, our sun is in mid-age. It will still continue to shine for another 5 billion years. Thereafter, the hydrogen content would have been exhausted. And when that happens, the interior will contract further. And that will cause the helium gas to heat up and produce some heavier elements like oxygen and carbon. This will not produce sufficient energy. Eventually, the inner core will collapse into a very dense state we call the neutron star or a black hole. The outermost part of such a star or our sun will be blown up in an explosion we call supernova explosion. The material so blown up will be scattered into the galaxy to begin another process. However, some of the heavier elements will come together to form bodies like planets that will end up revolving around the sun. That was how our Earth, our home, was born about 4.5 billion years ago. Madam Vice Chancellor, our Earth, our home, originally had no atmosphere. It was just a rocky planet. Over time, because of the gases that were produced as a result of chemical reaction, we had an atmosphere. Because of other chemical reactions, water molecules, and eventually we had the oceans. Sometime in the evolution of our Earth, some macromolecules were formed that were capable of reproducing themselves. This might shock some of us here. I know the genetic biologists will agree with me that we have what we call macromolecules that are intelligent. Those macromolecules will reproduce themselves. That was the beginning of evolution. That was the beginning of biology on Earth. It was as a result of these intelligent macromolecules that were formed in the oceans that evolution now proceeded on Earth. This evolution has led to us today. We are products of that evolution. Apart from the Big Bang that the general theory of relativity has given us, there were other phase transformations in the universe. Very early in the life of the universe, in fact, the fraction less than 1 second, there was what we call the inflationary Big Bang. There are observational evidences for all of this. There are observational evidences for the Big Bang theory. The workers who worked in this area evolved rewarded with the Nobel Prize in physics. And from our studies of massive galaxies, we are able to infer that the material we see in our galaxies is not sufficient to give to those galaxies the masses that we are able to measure. It means there must be some other materials in those galaxies that we cannot see. Such material we call dark matter. From also observational experiments, we know that our universe is not only expanding, the rate of expansion is increasing with time. It means there is a force that we call anti-gravity force. This force is what we call dark energy. In fact, the dark matter, the dark energy that we do not see, is more than the material things you can see. In fact, 4% of what you can see is the material world. Everything we see around us is only 4% of the content of our universe. 22% of the content of this universe is made up of dark matter, and 74% is made up of dark energy. I earlier told us that the big questions that are yet to be resolved in this study, what was before the Big Bang and what would be the ultimate fate of our universe, remain unresolved. Attempt to solve this problem, especially what was before the Big Bang, is what has given rise to the many religions that we have today. Unfortunately, for us to give scientific explanations To what was before the Big Bang? Like I said, we need another type of physics that we call quantum gravity. Unfortunately, there are so many hypotheses on quantum gravity that there's no one generally acceptable quantum gravity today. My humble contributions. In my foray into the study of high energy physics, I've worked on hypothetical particles under the supersymmetric model. In this model, the number of particles in the standard model is double. One of the particles I worked on in 2015 with my co-worker Duma was a particle called Chachino. We were able to measure the mass of this particle and find that the mass was higher than the masses of all the particles in the standard model. We also look at neutralinium. I worked with Ezekumon in 2016 on this, also using the supersymmetric model. And we discovered that even this particle could not satisfy the characteristics required for the dark matter, the elusive dark matter that we are still searching for today. I also branched into radio telescoping. In 2021, with my co-workers, we were able to assemble a simple radio telescope to measure the radio wave temperature of the moon and the sun. The telescope consisted of a satellite dish, very simple cost materials, a low noise block, an Arduino microcontroller, and a computer. This was successfully done in the Department of Physics, and I can say, without any fear of contradiction, that with this, we have been able to establish in the Department of Physics the ability to do basic experimental cosmology. I have also engaged my attention on global mass extinctions. Many may not be aware. Over the past 500 million years, our Earth has gone through 5 major extinctions. In fact, some people believe that we are passing through another 6th mass extinction. What's a mass extinction? When we have a mass extinction on the Earth, over 70% of all the plant and animal species will be wiped out. With my co-workers in 2021, we will look for the cause. However, we were able to show that this mass extinction occurs periodically, and the period is a cycle of 30 million years. We discovered that, interestingly, this is the time it takes the solar system to go up and down through the galactic disk and cross the center of the Milky Way galaxy. Our solar system is part of the Milky Way galaxy, and nothing is stationary, everything is in motion. The solar system is in motion, our Earth is part of the solar system, and it goes through the central disk and comes back down like that periodically, and it takes 30 billion years. And we discovered that mass extinction happens every 30 million years. This galactic plane is occupied by dust and dark matter particles. So it's possible, as the solar system passes through this galactic plane, space debris like comets will hold down towards the Earth to impact the crust and cause climatic change. This was what happened about 66 million years ago that resulted in wiping out of the dinosaurs. The dark matter also contained in this plane could also be absorbed into the Earth crust. And there will be mutual annihilation of this dark matter inside the crust, resulting in the rising of the temperature. And this over a million years could build up to such a level that could lead to volcanic eruptions that could also lead to climatic change. Another effect we discovered could be responsible for this is also the gamma ray burst from supernova explosion. If there is a supernova explosion within 10,000 light years from the Earth, this could damage our ozone layer. It could cause nitrogen and oxygen to form nitrogen dioxide, which is a gas we commonly call smog. This will block sunlight from reaching the Earth, leading to cooling of the Earth's surface and consequently the onset of the Ice Age. I've also done some work in the area of nuclear structure studies. 1987, I worked with Rator, where we used the rotation vibration model of the atomic nucleus. We were able to extend the work to 13 lowest bands, and this led to an improvement of the understanding of atomic nuclear structure in the literature. I've also looked at superconducting materials. Superconducting materials are materials that can transmit electric current without any loss. It's a novel kind of material. In 1992, Aiyohuyin were able to show that the Hamiltonians used by the BCS group and Urban have been recovered from the general Hamiltonian of the United States. In 2003, was able to show that there was a correlation between superconductivity and the displacive structural phase transition that could occur in a material. On superconducting materials, in 1994, I measured the coherence length, magnetic penetration depth, and non-magnetical magnetic field for bulk materials of high temperature conductors. All this work point to the fact that the kind of coupling in superconducting materials is an exotic one, not the usual in normal bonded materials. The Urban model is an interesting model. It gives a lot of insights into the kind of interactions that can take place between two electrons. And these interactions can lead to all kinds of phenomena like magnetic, insulating, and superconducting properties of solids. No wonder the intense interest on this model. I have done the specific heat energy of a Hubbard model, the entropy and energy of the system at finite temperature. And from our work, it is possible to predict the transition temperature from a normal state material to a superconducting material. I have also demonstrated that the Hubbard Hamiltonian can be transformed to the TJ model using the Rayleigh-Schrödinger perturbation expansion. We've also calculated transit properties of the Hubbard model, and this led to the fact that we're able to show that configuration interaction model and the exact technique agree. I have used this child space-time solutions to Einstein equation to try and attempt to calculate the mass of our Milky Way galaxy. From our calculations, that was in 2019, we were able to show that we have dark matter embedded in our solar system. The two big questions we have not answered them. Madam Vice Chancellor, before I end this lecture today, I wish to make my landmark contribution in this area, answering what was before the Big Bang and how will our universe end. These two questions are so important to the theoretical physicist that any acceptable solution will lead to a paradigm shift in our thinking and in the world of theoretical physics. I have understudied some great workers in this area. So I want to quickly agree with Hawking, 1988, who made a profound assumption that space-time is finite and has no boundary like the Earth. The universe is not infinite, it's finite. However, it has no boundary. That was Hawking's assumption in 1988. How does this sound? I will take us back to our Earth. Our Earth is also like that. Our Earth has no boundary. If I stand here now and I continue to walk and walk and walk, if I don't stop, I'm going to come back here again. Do you all agree? I will never get to a point where I say, oh yes, I'm touching the boundary of the Earth. The Earth has no boundary. This is the profound conclusion reached by Hawking in 1988, that our universe is like that, has no boundary. The only difference between our universe and the Earth is that the Earth is covered by the surface area, which is two-dimensional, body. He went on to say that our universe is a four-dimensional system and quantum world. Paul in 2022 also went on to say that that space-time and matter are inseparable aspects of the same physical reality. Many may not know how profound this is. That space-time and matter, they are inseparable aspects of the same reality. Before now, when Isaac Newton did his mechanics, space was seen as an absolute non-participant in the dynamics of our world. When Isaac came, Isaac said, no, space is not an uninterested observer. That space, that the matter contained in space, the matter is responsible for the curvature of space. And it is this curvature that we usually interpret as acceleration. Up to now, nobody has told us what is the material of space-time. This is what Paul assumed in 2022, that space-time and matter are inseparable aspects of the same physical reality. How profound this is will come to us later. He went on to make a number of axioms. For those who are interested, they are there. 1, 2, 3 axioms. However, the proposal that the universe has no boundary means that it is completely self-contained and not affected by anything outside of itself. It will neither be created nor destroyed. The universe is not like our earth. We know outside the earth, you have other bodies there. Not so for the universe. There is nothing outside there. The universe is just there. Self-contained. So there is nothing outside to affect it. Now, the observation that the fabric of space-time is expanding and its expansion is increasing and it's increasing has led some workers to predict that this will continue until a point is reached where the fabric of space-time will be ripped apart, just like a balloon. Take your balloon, you blow air into it, continues to expand, gets to its elastic limit, and that will happen. An apocalyptic end to the universe. I'm saying here, no. The universe will not end like that. The reason why the universe will not end like that is very simple. This is my contribution. As the rate of expansion of the universe is increasing, to continue to increase and come close to the speed of light. The speed of light, Madam Vice Chancellor, it is the highest speed attainable by any matter in our universe. Nothing can go beyond the speed of light. The reason why you cannot go beyond the speed of light, you will need an infinite amount of energy to get to the speed of light. And you cannot derive an infinite amount of energy. It doesn't exist. Similarly, as the fabric of space-time is increasing, and the acceleration is coming close to the speed of light, it will require an infinite amount of energy to sustain this expansion. A point will be reached where the inertia will overcome the dark force and the universe will start contracting. Madam Vice Chancellor, the silence is deadly. Yes. That's what is going to happen. The universe will start contracting and will start going back. Of course, as it's contracting, the bigger volume, bringing it to a smaller volume, the temperature will also be increasing. Of course, all the system will have now collapse. Everything will go down. We'll go back to before the Big Bang. When we get there, when the temperature is incredibly high, that the system can no longer contain the amount of energy. There will be another big bang, and we are about to the beginning. This is the cycle. What I'm saying is that, as a vice chancellor, we live in a cyclical universe. The end of one universe is the birth of another universe. Acknowledgements. I want to salute the great illuminated minds on whose shoulders I have stood so far to present this inaugural lecture. Dating back from the ancient Greek philosophers, who as far back as 340 BC were asking the same questions they're asking today. Nicholas Copernicus, Johannes Kepler, Galileo Galilei, Isaac Newton, Albert Einstein, the man who created the theory of relativity. Michael Simoni, Friedman, who predicted the expansion of the universe. Penzias and Wilson were the first person to observe the microwave background radiation. All these workers were rewarded with the Nobel Prize in Physics. Planck, Einstein, Schrödinger, Dirac, who contributed to the formulation of quantum physics. Thomson, Calvi, Galvan, who contributed much to our understanding of elementary particles. Pauling, Salam, Weinberg, Lashley, Rubia, my great mentor, Aiyohuyin, who as a city vice chancellor of the then University of Benin, Madam Vice Chancellor, still found time to initiate my PhD research. I want to also pay tribute to all the past deans of the Faculty of Physical Sciences. Professor Geben, Professor Okonwa, Professor Mosigo, Professor Aiyohuyin, Professor Sakete, and of course the incumbent, our innovative Professor Joseph Osayomwanbo. I wish to salute the past vice chancellors, namely Inaugural, during whose tenure I was employed in this university in 1996. Professor Nao, Professor Wanze, Oshoni of Blessed Memory, Baba Domo, Professor Rumes, and of course the incumbent, Professor Lilia Motinya Salami, the woman of uncommon courage and innovative skills. My numerous colleagues, the central laboratory of the university must be world class so as to attract jobs from across the globe. The personnel must be trained and retrained to be among the best. University of Benin must encourage staff to attract grants that lead to the setting up of centers of excellence in research and development. The University of Benin must encourage staff to establish linkages with the scientific international community through the provisions of the scientists. The University of Benin can set up a committee to identify local problems and provide incentives to staff to solve them. Madam Vice Chancellor, in this lecture, I have attempted to bring to the fore the preeminent position of physics in the study of the evolution of the universe. I have labored to show that physics is a conversation across many boundaries. Mankind has the same nature as the stars, and we are destined to return there. Nigeria cannot afford to be left behind in the quest to get a foothold in the cosmos. The research to conquer space must become part of our university curriculum. The research to understand the fundamental forces and particles is to unravel the ultimate reality and truth about our universe. This lecture has opened our eyes to the fact that our country can join the rest of the world to do research at the frontier of knowledge. Basic radio telescopes and basic particle detectors can be assembled here. We can ask fundamental scientific questions and we can probe nature using basic scientific methodology. Basic research should be encouraged in our universities. Finally, it is posited in this lecture that we live in a cyclical universe. The end of the universe is the birth of another. Thank you.
If you can do well to put our hands together for your lecturer. Thank you very much. I'm sure we all wanted to know how the universe would end. And today he has told us that there is no end to the universe. I'm sure we are all relieved. Please put your hands together for yourself. And now respectfully invite the Vice Chancellor to do a recap of the lecture.
Distinguished audience, ladies and gentlemen, we are obviously happy with Warren. And we have reason to be happy. After all, we've been told that the world will not end and none of us is going to hell. Is that not a reason to be happy? Is that not a reason to be happy? Somebody has said no, but whether we believe in the Big Bang theory or some other theories, I think that the lecturer deserves a sounding round. Ladies and gentlemen, Professor Emmanuel Aiyohuyin has described the four fundamental forces in the universe. I refer you to pages 3 and 4 of the booklet. I am not a physicist. I don't want to be one. The only little physics I remember, I suppose Professor Sadoni Provost also remembers, the Van Boosman's constant in thermodynamics. You remember? Is this sigma alpha? I don't like it. Omega R squared. Angular velocity, is that it? And so on that, but beyond that, don't ask me. I don't want to. Alright? He has sketched the evolution of the universe to the present using the language of cosmology. He touched on the ultimate fate of the universe. He described some exotic particles he has worked on. He has also done some work in radio astronomy. He has told us of his foray into the world of theoretical physics. Using the language of quantum gravity, he concluded that our universe is completely self-sustained and not affected by anything outside of itself. It will neither be created nor destroyed. He has made relevant recommendations calling on government and industry to fund the study and training of physicists. He also called for funding of physics research. Many persons in this distinguished audience may be disturbed by his theory of cosmology. But let us keep in mind that he is a devout Christian of the Catholic faith. And as he delivered his lecture, I was pleasantly surprised that my venerable professor was applauding the Big Bang theory and the fact that the world will not come to an end. So when the serving people will continue on Sunday next, and we're asking whether we are together or not. Well, one thing we can see is that in church on Sundays, Professor Aiyohuyin confesses that God created the universe. But in the laboratory on Mondays, he professes cosmology and that the world has no end and is self-sustaining. But let me remind you of his forebearer, Albert Einstein, who said that science without religion is lame and religion without science is blind. Madame VC wishes to recognize before all stakeholders that Professor Aiyohuyin is indeed a professor of physics of outstanding records and
the inaugural lecturer. Please, we invite members of his immediate family. Please come off stage. Spouse, children. Please come off stage. Thank you very much. We want to welcome Ms. Very especially the spouse of the inaugural lecturer, Mrs. Elizabeth Aiyohuyin. We also want to welcome Patrick Aiyohuyin, and Sohe Angela Aiyohuyin, Orobosa Emmanuel Aiyohuyin, Evosa Mary Aiyohuyin, and Etiosa Elizabeth Aiyohuyin. You're all welcome. We also like to make very welcome Emmanuel, the Eho of Benin Kingdom. Please come put our hands together. We also want to welcome Chief Osayomwanbo of Benin Kingdom and Okaigbe of the Eho family. Please put your hands together for our lecture. We want to welcome especially Emeritus Professor T.O.K. Awudu. Please put your hands together for him. We welcome especially Venerable Professor Aiyohuyin, Director of Academic Planning here at the University of Benin. We welcome you, Professor Aiyohuyin, UAB Chairman. Professor Mrs. Ogre, please put your hands together for her. We also welcome you, Professor Emmanuel. We also may very specially welcome Professor Obi Ajayi. We welcome Professor Iyamo. We also like to recognize the presence of Professor Jennifer Egbebe. We also welcome you, Professor C.O. Aibogo. Please put your hands together for Sir Patrick Kayiri, President ICOBA, 79 cents. We want to also make welcome Chief Barrister Percy Okoji. We recognize the presence of all ICOBA 79 sets. Please put your hands together for them. They are very powerfully represented. And also, we'd like to make welcome Engineer Dr. and Mrs. Osakai Kwede. And we recognize and appreciate your presence, Professor C.O. Aibogo. We welcome all scholars here, all HODs, all directors, all deans. You're again welcome. And for every guest, we say you're welcome. We thank you for being a part of the inaugural lecture today. And the inaugural lecturer has said that there's some refreshment for everyone, so there's no need to rush. There's refreshment for everyone. We will now be upstanding to take the closing formalities. We are going to observe the recession of the Vice Chancellor's procession. First, we'll take the Unibet anthem, and then the second stanza of the national anthem. Please be up the upstanding. Thank you.
Thank you. out of the auditorium.